I am taking the derivative of the function L of x, which is x squared over cosine x times tan x cubed over sine x times x squared, cosine x squared. I separated the L of x into two separate functions. The first half, which as you can see is x squared over cosine x times tan x cubed over sine x, is going to be f of x, and cosine x squared is going to be g of x. I started with cosine x squared because that was the easiest one to do, and I used the chain rule, and I separated that into two different functions again, and it would be a of x, which is cosine x, and b of x, which is x squared. I found the derivative of those two. A of x, the derivative of a of x would be negative sine x, and the derivative of b of x would be 2x. The chain rule would be the derivative of a with b of x inside times the derivative of b of x. So the derivative of g of x would be negative sine x squared times 2x. We'll keep that for later because that will be used in the end. And then moving on to the f of x, which requires more work. I first separated those two equations into c of x and d of x. I started with the x squared over cosine x, because it doesn't really matter which side you start with, they're both going to take a while. So I used the quotient rule, which it would be, because it's the x squared is over cosine x, I put x squared as the e of x and cosine x as f of x. I found the derivative of those, so I got e to the prime of x, e prime x equals 2 of x, and f prime x equals negative sine x. And the quotient rule would say e of x times f prime x minus e prime x times fx over e of x squared. So the equation would be x squared times negative sine x minus cosine x times 2x all over x squared, or x to the 4 if you want. And that would be c prime x. And then moving on to the tangent x cubed over sine x, which is d of x. I also used the quotient rule, but I had to find the derivative of t of x, so I had to use chain rule first. So for the chain rule, I made two different functions again, and it would be I and j. I of x would be tan x, and j of x would be x cubed. The I prime of x would be secant x squared, and j prime of x would be 3x squared. So the chain rule would be secant x cubed squared times 3 of x squared. And that was the derivative of t of x, which is tangent x cubed. And so the derivative of h of x, which is sine x, is just going to be cosine x. So the derivative of d of x, or tangent x cubed over sine x, is going to be tan x cubed times cosine x minus secant x cubed squared times 3x cubed times sine x all over tangent x cubed squared. And that's the d prime of x, and we'll be using that and c of x together to find derivative of f of x. We'll be using the product rule, which is c of x times d prime x plus d of x times c prime x. So I got x squared over cosine x times tangent x cubed times cosine x minus secant x cubed squared times 3x cubed times sine x all over tangent x cubed squared plus tangent x cubed over sine x times x squared times negative sine x minus cosine x times 2x all over x squared squared. And that is the derivative of f of x. And lastly, we use the product rule again to find the derivative of L of x, which would be f of x times g prime x plus g of x times f of x, prime x. And for that, I got a really long equation, which is x squared over cosine